Okay, so in this video we're going to review how to write CERs. And the idea behind writing a CER is basically conclusions based on data. And it's about answering a question not just with a claim but with evidence and reasoning. Because science is about explaining how things work, and so when you see a question you should be able to make a connection between answering the question and information that you already know that we've learned in class. So it's not just enough to have the right answer, you have to be able to justify why your answer is correct using evidence and using scientific reasoning. Okay, and so that is basically why CERs are important. Okay, so the way it works is this. CER stands for claim, evidence, and reasoning. And so when I give you a question and I ask you to respond using CER, that's what I'm talking about. Okay, so here are the three parts of CER. The first part is the claim. Okay, so I ask you a question, your answer to the question with no justification or reasoning, that is the claim. And we'll see some examples here in just a minute. The evidence, evidence could either be quantitative or qualitative. In this class, because this is physics, it's always going to be quantitative, meaning it's always going to be numbers based. Oftentimes you're going to have to do calculations as part of your evidence. But generally speaking, your evidence could be based off of any observations that you make as well. Okay, and then the reasoning is what makes the connection between your evidence and your claim. Okay, so basically is a scientific explanation that shows why does your evidence support your claim, and it ties everything together. And that reasoning often includes, scientific principles or background information that you know about the topic. Okay, so as we're writing CERs, just some things to keep in mind. Okay, be clear on your claim. Okay, your claim should be one sentence answering the question that's being asked. Now, in this class, a lot of the time you're going to have to do calculations, and you're actually going to need to do the evidence piece before you can answer the claim. Okay, that's normal. When you get to the evidence piece, make sure you include calculations, make sure you include equations, make sure you include units as part of your evidence. Okay? And so you want your evidence to be as specific as possible. And then when you get to the reasoning part, you're going to connect your evidence to your claim and again give the scientific reasoning behind why that evidence supports your claim. Use facts and not opinions. Okay, so here we're just going to look at two really quick examples of doing CERs so that you have an idea of what those should look like. And these are both pretty basic examples, but the ones we're going to do in class might be a little more involved because this is a physics class. So the first example we're going to look at is this one right here. Okay, so here we are given a set of data. You're always given some set of data with a CER, and we're given information about 4 liquids, about their density, their color, their mass, and their melting point. And the question that you're asked is, write a statement explaining whether or not any of the liquids are the same substance. Okay, so see if you can do this on your own. Using the claim, evidence, and reasoning format, try to answer this question. Okay, explain whether or not any of the liquids on this table are the same substance. Okay, so here's what you should have written as far as your claim, evidence, and reasoning goes. Okay, your claim should have ended up being liquids 1 and 4 are the same liquid. Okay, your evidence in this case is based off of the fact that liquids 1 and 4 have the same density. If you go back and look at the chart, they have the same density. It's 0.93 grams per milliliter. Okay, so this is actually a little mistake there. It should be 0.93 grams per milliliter. They have the same melting point. If you look at the chart, liquid 1 and 4 and have the same melting point. And they both have no color. Okay, so notice that in this case we didn't need to do any calculations for the evidence, but it was still based off of what we're given in the table. Now the reasoning connects the evidence to the claim. The reasoning is that these physical properties are unique to a particular substance because they have the same density and the same melting point. These two liquids must be exactly the same. Okay, and so CER is just a way of structuring your response to make sure not only do you answer the question, but you give evidence and you give reasoning connecting that evidence to your claim. Okay, so that is one really basic example of answering a question using CER. Let's do one that's a little bit more involved. Okay, so take a look at this here. We're given a set of data with some measurements of the length and width of rectangular pieces of paper. And we are asked the question, which of these rectangular papers or pieces of paper could be used to cover up the biggest possible paint stain on the floor? Answer question using CER. So based off of the length and the width in this table, and again, this is supposed to be a really basic type of thing. Obviously, the CERs we'll do in physics class are going to be more involved. But based off of the data you have available, which of these rectangular pieces of paper could be used to cover up the biggest paint stain on the floor? Answer question using claim, evidence, and reasoning. Okay, so this is one of those situations where you actually need to do the evidence piece before you can answer the claim, because in order to answer this question, you need to know which piece of paper has the biggest area. And so you actually have to do the calculation for each piece of paper. Okay, once you calculate the area, which the area of a rectangle is just length times width. Okay, so my pen is not working, that's fine. But it's just length times width. And so if you were to go and do the calculation and find the area of each of these pieces of paper, then what you would find is that paper 3 actually has the greatest area. Okay, so let's try this again. Area is length times width. And so if you do, 2 times 12 is 24. 4 times 10 is 40. 6 times 9 is 54. 8 times 6 is 48. And then 10 times 4 is 40. You can see that the one that has the greatest area is paper 3. And so again, you would have to do this calculation. Now here I didn't actually write out the work, but you would be expected to actually show the calculations on your paper along with the correct unit. So your answer for this question, if you answer correctly using claim, evidence, and reasoning, should look something like this. Okay, your claim, paper 3 would be able to cover up the biggest paint stain on the floor. Notice how that is a complete sentence. My claim is not paper number 3. My claim is paper number 3 would be able to cover up the biggest paint stain on the floor, because that's what I'm asked to answer in the question. Okay, so make sure you answer in complete, coherent sentences. For my evidence piece, notice the first thing I do is I state which equation is relevant. Then I actually go out and I do each of the calculations showing what I'm doing. This is me doing the area equation for each piece of paper, showing what the actual area is, including the units. Okay, that's meters squared. Okay, and so that whole thing is my evidence piece. Okay, so your evidence is usually going to involve calculations. It's usually going to involve units. You got to show all of your work and all that stuff. Okay, and then the reasoning connects the evidence to your claim. Because paper number 3 has the greatest area based off of my evidence, that means it would be able to cover up the largest size paint stain on the floor. Okay, that makes the connection between the evidence and the claim. Okay, so you saw 2 examples answering things with CER. Again, these are meant to be very basic examples. We'll do more advanced ones in this class, but that's just to give you an idea. So when you answer a CER, let's claim, evidence, and reasoning. Again, a lot of the time you want to start with the evidence piece, do any calculations you need to do, make sure you do them fully and completely with all the units and the equations written out, and then use that to answer the claim, and then use the reasoning to connect that evidence to the claim. Okay, so after watching this video, you should now be able to understand how to write a scientific response using claim, evidence, and reasoning. As always, please let me know if you have any questions, and I'll see you guys in the next video.